small table for a computer, WD-40 spraying system, new huge and powerful spindle, and many other upgrades. That's what I'm going to do in this video. All of that started with replacing the 12-volt power supply with 36 volts. A few days after this upgrade, TB6600 drivers stopped working properly and were pretty unreliable, so I replaced them, and after that just started adding a lot of upgrades to IndyMill, and that's what I want to share in this video. All those upgrades that I added to my machine, and also I would try to keep this video universal so that you can add similar upgrades to your CNC machine, and I will tell you what, in my opinion, are the best upgrades to a DIY CNC machine. As always, you can find all the links to files and things I'm talking about in the description. I don't really want to get into details why 36 volt is beneficial for a CNC machine and how it changes the behavior of stepper motors, because there is really a lot to talk about, but generally you can use higher feed rate and also you have bigger torque on the motors if you are using a bigger power supply. Of course, keep in mind that this power supply, the voltage of this power supply has to be compatible with stepper drivers and stepper motors that you are using and with other stuff on your CNC machine. So for example, with these drivers you can go, I think, up to 50 or 60 volts, but not higher than that, so 48 or 60 could be a good choice. Also remember that if you have something else powered with different voltage on your CNC machine, you cannot just connect it to 36 volts. For example, I have an LED strip that was connected to the 12-volt power supply, but right now I have the 36-volt power supply, so I added a voltage regulator, and now I can safely power the LED strip and some other stuff in the future. And as I said, 36 volts improves the feed rate and the torque of the motor, so you can run machine faster. Previously I was running it at 1000 millimeters per minute with 12-volt power supply, and right now with new power supply and new stepper motor drivers I can go as high as 2500 millimeters per minute, so that's, quite a difference. I also faced some problems with this power supply after only 3 months of using it. Probably it was connected to actually the power supply being broken and not me using it improperly. I hope so, because I measured a lot of stuff. I measured the power supply, stepper motors, drivers. I tried to power the machine with lab bench power supply. Alright, so here you have it on the screen. As you can see, the voltage was almost 36 volts, but once I started machining, it drops to 10 volts and then goes to like 14 and then 10 again, and something is definitely wrong with the power supply. So I sent it back to the producer and hopefully they will replace that, but as for now I bought a 36 volt power supply, 16.7 amps, which should be way more than enough for this machine. Previously I was using 11 amps. For over a year, TB6600 drivers were working fine for me, but right after replacing the power supply, those started to be pretty unreliable and I just wasn't able to use them on this machine anymore, so I replaced them with DM556. And those drivers work fine, they are a lot more quiet. It is so silent compared to TB6600. So this is the x-axis, and on the y-axis I still have the TB6600. Of course there are two motors, so it's a little bit louder, but compare that to the x-axis. The difference is huge, and the connection is basically pretty much the same. The driver is just a bit bigger, so keep that in mind. If you have a small electronics box, that may be a problem. And also keep in mind that this driver can only be powered with voltage higher than 24 volts. So if you have 12-volt power supply, you cannot use these drivers on your machine. Or you also have to replace the power supply together with the stepper drivers. And so far, after 3 months, the machine is working fine with those drivers and I had no problem at all. And also the machine is a bit more quiet. And also I decided to take a look inside the drivers to compare them internally, and here you can see that. When I finally started redesigning 3D printed parts for IndyMill, I realized how badly I actually designed them. There was just so much to improve. I designed and printed a few experimental parts, and once I was happy with the results, I released those on Industry and my GitHub. On GitHub you can also find both STL and step files in case you want to modify something. I also started selling 3D printed parts on my industry store, so if you want to build IndyMill but you don't have a 3D printer, you can just buy those 3D printed parts and build yourself an IndyMill and support my work. Oh, and I totally changed the ball screw block design. Now instead of truss bearing there is an additional ball bearing and printed flap. It is much stronger and works as it should, unlike the previous screw blocking design, because that was just such a terrible idea. Let's just pretend that it never existed. One thing worth mentioning is that 3D printed parts are surprisingly strong and definitely strong enough for such a CNC machine. Sure, making those parts out of aluminum would improve the machine a bit, but not really as much as some people may think. And also keep in mind that I'm not trying to build the one and only heavy-duty, big, powerful CNC machine right there. I'm trying to share with the world a CNC machine that is cool, easy to build, and considering what it can do is still quite affordable. Balancing all of those things at once is definitely not an easy thing to do, but I'm trying my best. That's how I have been using my CNC machine for a very long time. An old chair, my computer, USB cable and a pretty uncomfortable position. I have been overthinking this design and over-engineering it in my head for a very long time, but finally I decided to do it the simplest way possible, just a fixed table made out of wood, but firstly I had to add wooden panels to my CNC table. And the table for the computer is ready. It will go right here like so, and then with those two wooden pieces that I cut at an angle, I will just simply support it that way, one here and one in the back. And also to one of these angled pieces I will attach the safety switch that used to be right here, but it is not really that easily accessible now with the table in the front. So yeah, this is definitely a better place for a safety switch. I am way more happy with this table for the computer than I should probably be, and I'm not really sure why I waited so long to actually build this thing, because using the computer on a chair that was standing right here was not comfortable at all, and this thing is just so simple yet so amazing and definitely a great upgrade to a CNC machine. As you can see, I already prepared a piece of wood, everything is set up, and I just want to machine something cool just to see how this kind of wood will work with a CNC. And also I want to see if actually the dust collection system will be enough to keep the computer that close to the CNC machine clean, and if not, I will just grab this piece of plywood, cut it somewhere there and create some kind of a wall that will protect the computer from wood dust and aluminum chips and stuff like this. It is incredible how such a simple thing can improve the user experience and overall comfort of using the CNC machine. This is 10 out of 10 upgrade, totally recommend that. Adding a closed loop coolant system to this kind of a CNC machine is probably an overkill, but helping the cheap evacuation with compressed air and sometimes some WD-40 is definitely a great idea, and that's why I got this flexible nozzle that I can easily attach to the spindle plate. Quite fortunately, the distance between those two holes is exactly the same as the distance between the screws on the Z-axis plate, so I can just use longer screws and attach it to here. And if you have a different machine and there is no such place where you can just attach it with longer screws, you can machine some kind of an adapter or even 3D print some kind of an adapter or drill holes in the metal plates and attach it wherever you want. And then with 8mm pneumatic hose and a valve I can connect it to my air compressor that's honestly a bit too small for that. To test it, I made a filament spool holder for my CR10 on IndyMill because I actually lost the original one, and the air assist really helps a lot while machining aluminum. I also noticed that I can easily apply and safely apply WD-40 like so when needed, so I designed a 3D printed holder for that, and now with just one click I can spray some onto my material. Controlling the spindle with GRBL. I got so many emails, comments, questions about that, and yes, of course it is possible, but first you need to convert PWM signal to analog 0 to 10 volts, because it is 0 to 10 volts, right? Obviously it should be 0 to 10 volts, and the problem is it is not 0 to 10 volts, it's actually 0 to 5 volts, and I should check that in time, but I didn't, and it's not 0 to 10, it's 0 to 5 volts.
So this time I had no time to actually order the professional PCB, so I just made it myself, and here I'm cutting the transfer paper that is used to actually make the PCB, and I'm sticking it to the normal paper. That's how I'm usually making my PCBs, and I'm printing, and as you can see this one failed, and well, this one failed too, so I tried again, and this one failed too, so I tried a lot of times, and unfortunately without any success. Finally, somehow I got it to work as it should, so I grabbed a piece of PCB laminate, and that's how I'm preparing it for transferring with the iron. So here I am precisely placing the PCB on the laminate, and I also measure the temperature of the iron to make sure that everything is fine and that this PCB will actually work as it should. And here I am ironing that, and after ironing usually it's a good idea to use some water in order to take off the paper from the PCB. It's not really beautiful and perfect, but it should be fine. There are no super small SMD components. Here I am cleaning some paper, and now etching time. And then of course some soldering. And here is my testing rig. I connected that to the GRBL shield and the Arduino so that I can control it through CNC.js, and I also connected it to the oscilloscope to see if the voltage is fine and if everything works. As you can see, we have a very stable analog signal and we can go up to 10 volts, which is great. The PCB is working fine. I also drilled holes in the PCB after soldering because I had drill pairs at the workshop. Usually that's something you want to do before soldering, obviously. And then I fixed with 2 screws the PCB to the electronics box and also connected everything. I just connected it to the power supply of 500 watt spindle, to the GND and signal pin where the potentiometer was connected, and then a quick test. And actually I noticed a problem right here because the 500 watt spindle seemed to be a bit more powerful than it was before, so something definitely was wrong. Later I found out that actually it is controlled with 5 volts and not 10 volts as I thought. So here I am testing it with the oscilloscope again to see if actually everything is fine with my PCB, and it was. And then you can see a blink, and that's how I blew the fuse of the 500 watt spindle, and I have to buy a new one. So after blowing the fuse I had to stop the tests, but I was really happy that my PCB is working fine, and on GitHub here you can find all the files for that if you want to make it on your own. And here is the schematic, very simple, and here is also the PCB layout, and it's also very simple.
I would say that this thing is still work in progress, even though it is already working for spindles that are controlled with 0 to 10 volts, and modifying that for 0 to 5 volts is actually the matter of changing one voltage divider. I will probably make a separate video just about this PCB, because even though it's simple, it's also a pretty nice circuit. You can find all the files on my GitHub for this PCB, and maybe in the future at some point it will also be available on my store. And now another PCB. No one actually asked for this one, but I thought it would be cool to have more light around the milling bit, so I made a 500 watt spindle light.
Unfortunately, I forgot to record how I'm making this PCB. I made it actually on the Dremel CNC and it was fun, but took a few tries. Here is the final soldered PCB and it was glowing at the first try. And I'm protecting it with this spray varnish because there are flying aluminum chips and stuff. Here are some prototyping notes and I soldered 2 very long cables to it, and then with M4 screws I screw it to the spindle from the bottom. Spindle LED ring is installed and I also went with the cable through the cable chain and I soldered it to the LED strip that is below this aluminum profile. And that should work already, but it is not really tested yet, so let's test it. And it works! That is great, and yeah, so much light right now and you can easily see the spindle and the milling bit and what it is doing while it is doing. And also you can grab the dust shoe and attach it and you have still pretty nice light inside here.
It's just a simple PCB with 8 LEDs, but anyway, I will probably make a video just about that because I have an idea for an interesting experiment that I want to try. Files for this PCB are available on my GitHub, and maybe this PCB as a product, complete product with LEDs already soldered, will also be available on my store in the future. And finally, an upgrade that everyone was waiting for, including me, a 1.5 kilowatt spindle.
So firstly I had to prepare actually the spindle plate, and I used the 500 watt spindle plate. I attached it to IndyMill, fortunately before blowing the fuse of 500 watt spindle. In Fusion I prepared what you actually can see, and with this milling bit I marked the holes. I decided not to drill them because drilling steel on IndyMill is probably not the best idea. So I just marked the holes where they should be precisely. Of course you can do the same on the drill press and just mark them precisely with a caliper or a ruler, but that was just easier for me, and here I am drilling those holes on a drill press. And then with such a weird drilling bit, I'm not sure what's the name of that, I drilled the hole like so, just so that the head of a screw will actually hide in the plate, and that is important because actually this spindle is quite big. And now I'm cutting the cables for the 500 watt spindle, and I also soldered right there the XT30 connector, just so that I can easier replace the spindle if I need to in the future. And here is the new plate with the 3D printed mount for the nut, and I'm screwing it back to the linear rails. And to screw the 1.5 kilowatt spindle in place I used M6 16mm long screws. And you also need for this spindle an inverter. Usually you can buy just those two pieces combined in a kit, and this is how it looks like. Here you can open this flap and there you need to connect the cables. On the bottom you have to connect the 230 volts and cables for the motor, and on the top you have some control pins. I'm not really sure how to use them yet. I have to figure that out and somehow connect it to GRBL. Everything there is nicely labeled, so it's quite easy to connect. To connect this spindle to the inverter, we have to unscrew this plastic piece and then go with the cable through it so that we can later attach it safely. And of course we have to take insulation off the cables and then attach those 3 wires to the spindle. And then put back in place the plastic piece and screw the nut on top. And the other side of the cable has to be of course connected to the inverter. First you go with it through this rubber piece. And here I am connecting the 230 volts, the L and N. If you are not sure how to do this properly, ask for help because you know it's dangerous stuff, it's high voltage. And here are 3 cables for the motor. And here's the first test. Actually it was working very well and there was no problem at all with it. And of course you can attach the inverter to your CNC table, and I also wanted to attach the coolant nozzle right there, but right now it is not possible, so I designed a small plate that I wanted to make out of aluminum, and I installed the milling bit to mill something for the first time with the new spindle. And I actually faced a problem, because the sound was just terrible, vibrations, the aluminum was really hot and I had no idea what is the problem. So I tried again, I broke the milling bit and then I moved to plywood just for a test and it was bad too. I'm a bit sick right now, so that may explain this small mistake, because I forgot to check actually the direction that the spindle is spinning in,
and it is spinning in the wrong direction. So I was trying to cut aluminum and plywood with the spindle going the wrong way. And for some reason it actually was successful for the plywood, kind of, and almost successful for the aluminum. That actually explains why the aluminum was overheating so much and why the plywood was so hard to cut. So now I will fix this simple error. Fortunately it's just one button, and I will try again.
I know, it's a really stupid error, but it took me some time to actually figure that out, and fortunately it was just about pressing one button on the inverter to fix that. And finally it was not only successful, but it was extremely easy to machine aluminum. I felt pretty confident and I achieved a pretty decent feed rate and really nice depth of cut, and also the final result was actually, I think, great. Here you can see it, after cleaning of course, and well, it looks great. It took like 3 or 4 minutes to machine this piece. And thanks to this simple aluminum part, I can attach the coolant nozzle easily to the spindle, and here I am attaching the dust collection system with duct tape to machine the dust shoe for this 1.5 kilowatt spindle. I actually made a separate video just about making the dust shoe for 500 watt spindle, so if you want to know how to make something like this and make it on your own, you can check out this video. Basically it's just 10mm plywood, 2-part piece with some magnets to attach it, and I painted it black to just make it look cool. And here I will put in place all the magnets. And here you can install the holes. This black part is 3D printed. And here is the bottom part of the dust shoe with the skirt, and you can just put it in place with the magnets. And this is just a simple last milling job for this video that I decided to make because I needed a handle for a drawer that I'm building, and I made it just to test the dust collection system and see how everything works so far, and it works great. As you can see, there is not really a lot of dust on the machine and we have a nice handle for the drawer.
I was waiting with this upgrade for so long because I actually wanted to show in my videos that 500 watt spindle is pretty capable and that you can do actually a lot, and for some people it may be a good choice, and especially for beginners, and I still think that's true. But 3 times more power and overall better quality is really making a difference.
So in the end, to summarize, what are the best upgrades to a CNC machine in my opinion? Of course it all depends, and some upgrades that didn't really work for me might totally work for you. I decided to divide the upgrades into 3 groups and also consider upgrades from my previous videos. So the first group is upgrades that you really need, must-haves, and that either improve the safety of the machine or overall greatly improve how the machine is working. And that's obviously the power supply, stepper motor drivers, 3D printed parts, safety switch, and some other stuff. And then there is some additional stuff, things that are really cool to have, but you don't really need them to machine something. And that's, for example, some additional light, like the LED strip, or the spindle light, the coolant system that is great, but you can still machine aluminum without it. Clamping system is actually pretty useful, and 1.5 kilowatt spindle, which is super powerful and great to have, but still 500 watt spindle is quite capable and you can do a lot with it. And then there are upgrades that of course might be cool and totally necessary for some people. I'm just not really using those that often, so well, you can add them, but I don't really think it is that crucial.
Adding upgrades is always fun, and hopefully I will add even more upgrades in the future. If you have any idea for the upgrades, let me know about that in the comments, because I always read every single comment under my video, so thanks for all the comments. And don't forget to check out industry.cc. You can find all the files for IndyMill here for free, and you can also buy the parts from my store to support my work, and you can also support my work on Patreon. Thanks a lot for everything. You can find all the links in the description, and see you in the next video. Bye!